Hello, I'm Jit Wachtlings, working for Threefold Tech, and I thank the OpenNebula team that I'm able to present here to all Threefold and what our open source technology is capable of to achieve a global cloud edge infrastructure, and also to explain how we intend to collaborate in the near future. So who are we? Well, Threefold Tech is a Belgian company that has created, to our knowledge, the world's first truly autonomous and decentralized cloud technology. You could say that we have developed the technology that is equivalent to what solar panels mean to the energy sector. Next to big power plants, solar panels are able to generate energy on a small scale. In the IT industry, three nodes are cloud capacity infrastructure that can run very locally in any size and without the need to have system operators around. We have proven our technology already, as we already have rolled out our decentralized model. It's up and running in more than 70 countries with more than 3,000 independent cloud providers called farmers. And these farmers directly benefit from connecting their hardware infrastructure to the Threefold grid, as on a monthly basis, they are rewarded with a passive income in the form of tokens. Behind the scenes, we have a toolkit that ensures many aspects that we consider as mandatory for decentralized cloud to be really usable in real life. Here you can see a few requirements. I split it up in three categories, an operational category, a commercial part, and thirdly, a governance part, as I believe that there are really three angles to the problem. Now, a first thing is trustworthiness in the availability of the hardware to operate in a way that SLAs can be made with it. Then also make sure that an ecosystem is made that is interoperable between hardware providers. Automation and scalability are also topics to be addressed, and these go hand in hand. Resilience as a whole ecosystem is required to both hardware failures and power outages, disconnection from the internet of certain devices, in summary, all kinds of unhappy events that might occur. That also includes security and privacy enabling topics. There's also resilience needed against malicious intruders, against hackers. So basically, security and privacy issues need to get a high degree of attention. And this is what Threefold has an answer to by design. Also, sustainability is something to look at as a category of operationalization. Again, I believe it's important to pursue this sustainability from an ecosystem perspective and not from each device or cloud provider individually. Current IT consumes about 10% of the global electricity, and that percentage is even rising. I believe it's our obligation as a society to take up these sustainability goals into the operationalization of a cloud ecosystem. Also, it needs to be compliant with regulation. A very well-known example is GDPR. In a federated system, GDPR compliance gets more complicated as there is a risk for leakages of data in transit between different devices. Especially for use cases involving personal or confidential data, that will really require hard guarantees that the data has not leaked. As an example, on finance, on health, on identity, in other words, use cases that process really private information. And then another compliance is that is anti-money laundering and KYC and embargoes regulation. You have to know that companies can get sanctioned with huge fines if they provide services to blacklisted countries or terrorist organizations, or if payments happen that fund criminal activities, even on European soil. Now, in a multi-user and a multi-provider setup, this is a high complex thing. In follow-up of this practice, it's really complicated. And then there's also complexity on setting up an ecosystem from a commercial perspective. Again, multiple users and multiple providers interacting in one contract make that a classic contracting and payment system becomes sheer impossible. And moreover, when it comes to payment, there is even a bigger headache issue like the correct VAT application if multiple jurisdictions are involved in one setup. And then a last topic to be addressed is governance. There's a neutral instance needed to create a level playing field by design between hardware capacity providers, where all providers are on an equal level in terms of rights and obligations, and get also a fair share in the revenue that the ecosystem generates. Threefold has developed an open source solution which takes up all these challenges. The technology is basically a combination of three elements. There's an open source Linux-based federated operating system. There's extensive automation so that no human intervention is needed anymore to maintain the system. And then the third component is a blockchain component bringing the trust. The first and most essential component of our technology is an operating system. This is the right way, I believe, to achieve real decentralization, as only at the level very close to the hardware, where you have the best control to make storage, compute, and network interact in a secure, fast, and privacy-enabling way, you can be sure it becomes endlessly scalable without holes in the system. So we have developed that operating system. We call it Zero OS. It has a Linux kernel inside, so it's compatible for running any Linux workload on it, containers, Kubernetes clusters, all types of storage, any application, you name it. But the Linux kernel has no features for federation in itself, and this is why all around the kernel has been rebuilt in order to make it federated, multi-user, secure, and privacy-enabling. We make it multi-user because access to this operating system, both as a provider and as a user, happens through a public-private key pair, the same as is used, for example, to secure blockchain identities. So every user, human, could also be an IoT device, has his own identity represented by his own private keys and interacting directly on operating system level. So this OS has a Linux kernel inside, but all around has been rebuilt from scratch to enable full security and privacy enabling by design. First of all, there's persistent storage, where data can be dispersed intelligently over different hardware storage devices, which could be owned by different cloud service providers. Hacking into a hard drive becomes useless then, as data is incomplete and encrypted. It's why we call it quantum safe. When with incomplete data, even a quantum computer cannot reveal the original information. We got rid of a hacking surface of this operating system as it runs only in memory. There's no shell. It completely separates the capacity providing side from the usage and data running on it, meaning that a hardware provider has no insight whatsoever on the workload and the data running on this infrastructure, which is essential to have privacy implemented by design. Third component is a network, which is by design end-to-end encrypted and with strong authentication features to connect. This network can securely interconnect any two hardware devices over IPv6 with a secure protocol. And then a fourth element that had to be worked on addresses both scalability and interoperability. It's about the full automation of this deployment process. It's the so-called smart contract for IT. This includes also self-healing. So if a node goes down, other hardware can take over. Now, the combination of all this brings the following benefits. First of all, compute and network can interact in a secure way, and that with standard hardware on the market in terms of CPU, storage, and memory. Linux is inside, so any Linux workload can run, like containers, Kubernetes clusters, storage solutions. Decentralization often blocks scalability. We see the blockchain scene struggle with this. Not in our case, as millions of nodes can be connected. Reliability is embedded using the features to achieve redundancy with very small overhead. We have security and privacy by design, discussed that, and our model is open source, of course. Now, important for OpenNebula also is that the technology can run both on small and big devices, making it available for the edge and also feasible to implant anywhere, given the very light energy requirements. We have an incentive embedded through a token economy, useful for edge cloud providers to get their fair share of the ecosystem. The technology can be set up with a very limited cost, using standard hardware and in a small scale, if needed. We're working on making the technology available also on ARM infrastructure such as Raspberry Pi, so it can even become available on more devices. Okay, here you see a nice summary and a comparison with a centralized cloud, which has reached its limits in scalability, basically, and potential for further rollout. Now, in order to achieve this full scalability, we are also working on a multi-level approach, with supernodes being the well-connected hardware infrastructure, which also secure the network, next to smaller nodes that are linked to these supernodes. We have a concrete example of these ideas to be built into a new business model. We now have a partnership with a real estate company to create the world's first so-called neighborhood cloud in a residential area in Dubai, bringing the cloud business into residential houses and hereby giving the benefit to the people to run plug-and-play cloud infrastructure and earn a passive income from it, while it opens up to these people to get really fast internet that is completely at the edge. It's something that will be an essential component also for the metaverse, for example. And then we're happy to announce that we have made a partnership also with OpenNebula to explore the integration of our technologies and to bring it to the edge. It's about integration of the technologies and providing the grid, for example, in OpenNebula's provider catalog. It's also about reference cases in new industries. OpenNebula has invited us to join their IPCEI-CIS project, and we thank them for that, to build this federated operating system to run at the edge. We are mostly involved in Gaia-X, the big European federated cloud project, as we have developed the technology for a cloud federation, a role which is pretty essential in the Gaia-X architecture. But apart from us, no mature solutions seem to exist on the market, and we'd like to have OpenNebula also as a partner within Gaia-X. And we have also plans to participate together in European initiatives, such as the Digital Euro program. So yes, I'm pretty excited to start this new journey together with OpenNebula. You can find a lot more in our wiki. The URL is given here. And I'm of course available to discuss anything that you need to know around our technology and collaboration. I thank you a lot for joining, and I wish you all a pleasant rest of the day. Thank you.